I'll introduce myself. I'm Prableen Kukreja. I'm from IIT Tirupati, PMRF research scholar doing PhD. So my area is basically distributed machine learning with networks, like focusing on the federated learning part. And I'm also using RL concepts. So in which the probability is the main core, I can say, in ML, DL, RL, everywhere. So let's now proceed with the probability course. How is it going? Like yesterday, you all attended the class so that I can know it shouldn't be an overlap. Am I audible? First thing, my screen is visible. Okay, you're asking AI is my domain. I can say specifically I'm focusing on FL, federated learning. I'll tell you sometime what is basically the FL thing. It is distributed machine learning, I can say. So it comes under AI, like a subset of that, not proper AI. And using these optimization techniques or RL techniques also. Last time I was the TA of reinforcement learning. And this time I thought, okay, let's have some like hands-on on probability. So how is the course going? I think in the first week, you can also unmute your mic and speak. So in the first week, I think only basics are covered. After that, I think the professor has started in the week 2, the conditional probability and all. First week is just the intuition. What is the intuition behind the probability and how is it going? I think so. So you have gone through the video lectures. So we'll go step by step covering all those previous assignments which are done and also giving the intuition for the next assignments also and more of intuitive understanding of whatever is covered in the lecture. So let us start. First of all, what do you think? What do you mean by probability? Let us make this session as an interactive one. It shouldn't be like I am only speaking and you guys are listening. Let's make it as an interactive session. So what is probability? A simple question. First, before starting the course, let us first discuss about the probability. Yes, someone, can you unmute or write in the chat? Unmute your mic or write.
Ma'am, probability is a measure of uncertainty or certainty of an event.
Yes, absolutely correct that it's uncertainty or certainty of event. Or I can say that it's the frequency of the occurrence of the event. If an event is uncertain, we say that how much frequently that event can occur. That is basically the probability. What we are interested in calculating likelihood of the occurrence. So with what probability, with what likelihood, we can say that that event will occur. That is basically, I can say that is the probability. Or if I have to like write mathematically, I can say what are the favorable possibilities of that event to occur? Overall possibilities. Today we'll just go through the basic as week 1. Then from the next on we'll like go ahead like by conditional probability based theorem and all, whatever you have covered in week 2 basically. So let us first try to understand this sets and all. Like you have also seen that we have used union, intersection, complement, and how all of these lemmas and all. So let us try to understand these also in this lecture. So our main motive is like we want to assign, I can say, probability to an event from the sample space. Can someone tell me what is sample space? Today the lecture will be a basic one. Then we'll go ahead. From very basic, I'm starting. Can someone tell me what is sample space? Yes, come on. Yes. Sample space, someone has written sample space is a set of all possible outcomes. Absolutely correct. So I have all possible outcomes and we have to assign the probability to a particular event from that all possible outcomes. So I can say it as whole universe and I can mention it as omega here. Now coming to some basic properties of this. Let us try to understand it mathematically as well. So what do you mean by this? Yes, come on. Yes.
Sum of all events of the sample space is equal to 1.
Yes. So sum of all event space, basically all the events which are happening from the universe, that is basically some from the like sample space, that sum is equal to 1. That is what it is. Your voice is not clear. Anyone is having doubt? Okay, let's proceed. So I'm thinking either to go by sets or if I talk about sets, can someone tell me what is set? Though it's not discussed in the class, but still we have used the inclusion exclusion principle and all. So for that, we should know the basics of sets as well. So yes, what is set? Simple in layman language. It is a collection of distinct elements. Absolutely correct. So if I say that this is the collection of the distinct objects. Okay, now another thing. What is countably infinite set and what is uncountable set? Can someone tell me the difference? Yes, come on. Something that maps onto natural and not is countably infinite. Yes, absolutely correct. So can you give me the example of uncountable as well? 2 power n, yes. So I can say that someone which is mapping to the natural, which is less, if it is more than the elements of the natural number in easy way, can I say that it is uncountably infinite set, which we cannot map? Is it the right definition? Okay, if I talk about set of real numbers, what do you think? Is it countably infinite set or uncountable infinite set? Okay, voice is not audible.
No, ma'am,
For
it's
other, okay.
ma'am, set of real numbers is countably infinite set.
How it is countably infinite set? And why not uncountable infinite set? Yes, actually it is uncountably infinite set. As I told, if we are able to map it as if a simple definition, I'll say you, if the elements are more than the set of natural numbers, then we say they are uncountably infinite. As we are having the, or we can say real numbers also, like real numbers or irrational numbers, as they are more than the set of natural numbers, we are unable to map in the list in the form of set. That is why we are saying that is uncountably infinite set. Is it clear? Any doubts? Should I
Ma'am, one example.
Yes.
Ma'am, could you please give one more example of this?
Okay. If I say set of natural numbers, that is simple. That is countably. If I say outcome of a die, that is also okay. That is countable only, not infinite. Also, set of even numbers. If I say, then that is countably infinite. If I say rational numbers, we cannot map it to nat. They are more than natural numbers. Then it is uncountably infinite. Easy way.
Okay, ma'am.
More
Clear.
elements in set of natural numbers, it is like real numbers, irrational numbers, so they are, we cannot map it into a set basically, so that is uncountably infinite. Is it fine?
Yes, ma'am.
Okay, now let's go to some operations of sets basically. Complement. So can I write it like this? Can someone read it what I have written? And what is this? Like, can someone read it? Or write it? I've just written the definition of complement. Just someone can read it. Like, give it a chance. Whether it's wrong, also it's fine. Try to read.
The complement is the set of all x's such that x belongs to omega, and or x is not an element of x. S.
So we can say x belongs to omega such that x does not belong to s. We can read it as such that or given that. So basically x belongs to omega and x does not belongs to s. What can we say that it belongs to it doesn't belong to that particular S set. So can I say it belongs to S complement because it is belonging to whole universe, like whole sample space? Is it correct to say if it belongs to whole sample space and it does not belongs to particular S, then we can say this is basically the S complement. Is it correct? Yes. Okay. Now coming to union. I can say S or T or both. That is basically the union, which means that S union T, I can write it as X such that X belongs to S or X belongs to T. Is it correct? And through Venn diagram, I can show it as S is belonging to, like X is belonging to S or S is belonging to T or S is belonging to both basically. Should I proceed? Now coming to intersection. Basically intersection is and S should belong to S and S should belong to T. So can I say this is intersection? It is belonging to S as well as it is belonging to T. Now, exploring more about Venn diagram, can someone tell me which portion will be like shaded in S intersection T complement? I'm going through very basics right now. Will enhance the level. S intersection T complement, yes. Oh, first I should write actually what is S and what is T, yes. Which portion will be shaded? Yes, you are okay. S by T, yes, you are right. Which portion will be shaded? Okay. I think okay. It's difficult to tell verbally basically. Is it correct as you told S by T? So basically T complement means that I'll show you. This portion here will not be shaded because it is coming in T, and portion of S which is not coming in T, that should be shaded. That is basically this portion. What is subset? S is the subset of T. So how it will be drawn? Can anyone tell me? Yes. A set where each member is also the member of the parent set. Absolutely correct. Like two concentric circles. Yes. All others are getting like how there are two concentric circles. So basically it's easy only that a set as it's written in the chart, a set where each member is also the member of the parent set, whatever is in the set, it is each member is also the member of the parent set, that is basically the subset. If I say S is subset of T and T is subset of S, can you infer something? S, the members of S are belonging to T and T are belonging to S. Yes, absolutely correct. We can say that they are both are equal. If my sum, okay, I can show you like sum of the elements 1, 2, 3, S and T, 1, 2, 3, 4. In this case, S is the subset of T. And suppose 1, 2, 3. Now T is also the subset of S. This condition can only be there if both are equal. One is in the other and other is in the first one. So if both are equal, only it can be there. That is why two concentric circles are there. Okay, what do you mean by disjoint set?
No elements are common in both the set.
Yes, absolutely
Intersection
correct.
is 0.
Yes, intersection is 0. So I can say that they are basically disjoint set. So these were the basics of Venn diagram and all of the sets basically. Now, just we'll touch it and then we'll go again to the part. So what is De Morgan's law? I can say that A union B complement is equal to A complement intersection B complement. Similarly, we'll go through it, the questions also. Today we'll solve the basic questions of this also so that there'll be more clarity. Or I can say that this is same written as this only. And similarly, same written as individually, if they are union, they are complemented, and if together intersected. That is what I have written here.
How
Yes. Any doubt? Okay, let's proceed. Okay. So you got what is basically the sample space. And I can say that we were talking about, we have used the term events also, like one event is occurring or other event is occurring. Can I say that subset of sample space is event? Is it correct to say this statement? Is it correct or not? Or I can say the collection of possible outcomes. Basically, sample spaces, whatever the possible outcomes are there. And if I talk about subset of sample space, that is basically an event only. Come to that now. Other property, just I'm covering the basic, that's why I'm going like fast only, because this you already know. Can I say it's non-negative probability? Other property, additivity. I think I should first go for disjoint events, which means where intersection is zero, where there is no intersection. As we have studied that disjoint means there is no intersection, we can simply add the probabilities. Okay. Let us now go to some questions and try to solve them. So in the class, there was a question like a fair coin when tossed. We know that what is the probability of head or tail? I can say that it's 50% because it's unbiased coin. And one more thing I have to tell. Can you tell me what is the probability of event plus complement of event? Yes. 1 basically. Now let us go through the question. A die. Am I not going fast or is it fine? Because these are just the basics, that's why. Now let us come to question. A dice has 6 sides. Roll 2 dices to get numbers x and y. Okay. What is the probability that sum is prime? Class, you have done co-prime. So you understood what is co-prime first of all. I'm not talking about prime. Co-prime means which they don't share a common factor other than 1 basically. Now we are talking about prime, a similar question. So I need you guys to solve. Try to help me. I want also. Okay. Probability of x, y, and sum is prime basically. Yes, someone can help me. Yes. Take your time.
just to get us started, we can start with the number of primes between 1 and 12.
Yes.
Because, sorry, between 2 and 12, since those would be the minimum and maximum amounts that we can get from the sum of two dices. So 2 is a prime, 3 is a prime, 5, 7, and 11 can be the possible outputs. And we can get all combinations of our dice rolls that give us those outputs.
Can I say 1, 1?
Yes.
Can I say 1, 2, 2, 1?
Yes. Are the dices distinct in our example?
Yes,
So
they are
would we count 1, 2, and 2, 1 as a...
different basically.
Okay. So for 5, 1, 4, 4, 1, 2, 3, and 3, 2. And so on.
And for 7, I can say 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. For 11, I can say 5, 6, and 6, 5. So basically 1, 2, 4, 6 ways, and 2 ways. So 1 plus 2 plus 4 plus 6 plus 2 ways, I can say 15. Right. Are we using this additive property basically? And okay, there was a very nice question. Are they distinguishable or indistinguishable? Can you explain or someone explain what is the difference between distinguishable or indistinguishable?
Well, if the two dices were indistinguishable, the outcome 2, 1 or 1, 2, the order of the outcome would not make a difference. But I'm a bit confused on this definition as well.
It means the two dies are different. Basically, different means like suppose okay, I can say one dies of there are basically two different dies, one red color die and one blue color die. They are different basically. Indistinguishable means they are not different. So 1, 2, and 2, 1. Yes, we can think of all this also. Let us take an assignment problem, do some brainstorming, and tell me like in the next class. I'll suggest you only. Was this example cleared? Like she has asked the question if it is indistinguishable or distinguishable. Should it change? Like should we consider only 1, 2, and 2, 1? I'll ask this in the next class. Like only one pair should be considered, like 1, 2 only should be considered, or 2, 1 should be considered, or both should be considered in both the cases. Let's take it as homework problem. Next Saturday, we'll discuss about this. And we'll go more like, I want the answer from you guys only. Like, what do you think about this?
ये हाल का है लो ले लिया
Any
ले लिया
doubt? Okay, let's proceed. Yeah, I was having a question here. Consider an experiment involving 3 coins. So what will be the outcome? I can say that okay, before heading to the outcome, what is the probability? two head will occur. I can simply say this is a very easy question. The sample space head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and tail, tail, tail. So simply I can say that what is the probability of occurring two heads? Can I write like this? Can someone tell me the answer now? Everything is given. Yes. Yes, come on. 3 by 8. Absolutely correct. So basically 1 by 3 probability of this, 1 by, oh sorry, 1 by 8 probability of this, 1 by 8 of this, 1 by 8 of this. I can say 3 by 8. Yes, you all are correct. It's 3 by 8 only. Now, heading towards the other basic problem, very basic problem. We'll raise the level. Suppose I have four-sided die. And that is a fair dice. Can you tell me what is the difference between, okay, not of dice, biased coin or biased dice also, biased coin first of all, unbiased coin and biased coin? Is there a difference? Yes, come on. What is, why we are using this fair, unbiased and all these terms? In normal world, what is the meaning of biased? Someone is biased. Yes, come on. The probability of getting or head tail is exactly the same in unbiased coin. Yes, there is no partiality. I can say each of them is having the equal probability, equal chances of both heads and tail. All sample points have equal chances. So if I have a coin with both heads, obviously that is a biased coin, as you said, that it's not the Riddler's two-headed coin, for instance. Yes, you are correct. So let us take a fair four-sided coin, basically. Oh, sorry, dice, basically. And we are assuming that this is fair, and we interpret that we are having 16 possible outcomes. And IGR 1, 2, 3, and 4 with this is the pair, and has the probability of 1 by 16. So what is the probability that sum of rolls is even? This is the sample space, basically like this. 16 sample spaces are there. Can I say half of them will be even? So 8 by 16. Is it correct? And same for odd, 8 by 16. What is the probability? First roll, now give me the answer. First roll is equal to the second. Yes, simple. Just basic I am touching. It's school days probability. This is the first question. First roll is larger than the second, at least one role is equal to 4. Okay, 1/4 and someone has written 4/16. Okay, same only. So you are correct. 4/16 or 1/4. Second, first rule greater than the second. I'm not solving it because it's simple only. Second, 6/16. Correct. Third, yes, come on. Third, at least one role is equal to 4. Yes, 7/16. Correct. Any doubt that you want that I should basically solve it? Nothing is there in the last also. At least one role, 4/1, 4/2. I can say 4/3, 4/4. I can say, and then reverse this basically 1/4, 2/4, 3/4. So basically 7/16. It was simple only. A is the subset of B. Can I say the probability of A? How can I say that? Can someone tell me?
Since we calculate probability by calculating the amount of favorable outcomes divided by the total outcomes, since the elements of A are all elements of B as well, we can just say that they'll be lesser.
Absolutely correct. So elements of A are already in elements like B basically, and B has some extra elements I can say which are not in A. So probability of that occurrence is also counted in probability of B. So that's why we can say that probability of A is less than equal to probability of B only. Okay. First I want to ask you you want me to there was a question solved in the class of that equilateral triangle and the circle basically. You want me to give the intuition behind that in more detail or I can say to solve that like how they have done the processes, because similar question is also asked in the assignment as well. Okay, yes. Let's go through that same question only. So the question says, first of all, why we came to that question, that is like sometimes the intuition is also necessary and we can have many answers of that question. Okay, let's first proceed to that. An equilateral triangle ABC in unit circle centered at O. Draw random chord DE. What is the probability DE is greater than AB? So what are they asking? Let us have an equilateral triangle ABC in unit circle which is centered at O. Draw a random chord DE. What is the probability that the random chord DE will be greater than AB? So basically 3 processes are given here of, and then each is having different answer here. That is what it is shown. What do you mean by unit circle? First of all, let us try to get it each and everything. What do you mean by unit circle? The question is saying unit circle. What do you mean by that?
A circle with diameter.
Yes, yes, yes. Yes. You were speaking something? Yes, you are correct, all of you, that radius is equal to 1. That is basically the unit circle. So let us go to the process 1. Suppose if we take select E basically, and DE basically is the chord. With loss of generality, we are saying that A is equal to D. Then what is the probability? This is the first thing which we tried to do, that DE is greater than AB. I want this as it is discussed in the class. Just we are having the quick recap who were unable to, like, as you also said, you guys said in the chat that we should do that question because it's more of intuitive based. What we are doing, trying to do here, why I'm trying to draw the arc here? Can I draw it here, here, or somewhere? And why in between? Like, what is it specific that I'm drawing the arc between BC to make it larger? It is all intuition based. Yes, come on, let's try. Come on, let's try. A wild guess. I draw an arc, like chord basically, DE, where I put that D with the A only, A is equal to D, and E I put in between BC. Can I say that if I keep that E in AB, I can't guarantee that chord will be larger than one of the side, larger than AB? Or if I put that arc between AC, then also it is looking like that that chord will not be larger. Am I correct by saying these two statements? There are 3 options for me. Either if he lies in AB, yes, someone has, or AC, DE will be shorter than AB. Yes, absolutely correct. So I put my arc basically in between BC. So that was, I can, why I didn't put here, as you have mentioned, that it will be shorter than AB. That's why we thought, okay, let's put in BC, like in between BC basically. So now what will be the probability? I was having 3 combinations. I put in one of them. So can I say 1 by 3 here? Second process. Okay, I put that arc basically in between that BC here. Second. Okay, we thought, okay, let us take this ABC again and we draw a circle, inscribed circle. This is O basically. I'm picking a random point F and then picking chord whose midpoint is F basically. So I pick that point F and the midpoint of pick that chord whose midpoint is F and F falls in inscribed circle. So what now I am saying is that if F falls in that inscribed circle, then only my chord will be greater. Is it correct or not? What do you think? We have to think intuitively. It's not any like formula based. If I think that if my F is falling between this inscribed circle, then it is basically, now what is the radius of it, that inscribed circle? One by two. How 1 by 2? Preshit?
I apologize, I'm short on time, and I had a very specific question about this
Yes.
paradox to ask. Do you mind if I ask it now?
Yes, yes.
Okay, so when you were talking about distinct and indistinct elements of sets, we talked about how the probabilities would differ if the elements were indistinct. So in process 2 and process 3, the way we're choosing the chords, I think that there should be symmetry problems with them. So specifically in the second process, when you choose the distance between the origin and the midpoint F, uh, there must be uh, there must be at least two different so if the midpoint is the origin itself,
Okay. Okay.
you can see that there's several chords that would be described by that, right? And we're
Yes.
counting all of those as one example.
Yes, actually, we are counting all of those as one. Okay, if you think that F is only, that is what is your question?
Yes, and you see that there's like very many chords that would be described by that example. So it's not that all three processes are counting the same thing, at least not in my estimation.
Yes, yes, yes.
So
Actually,
there
we
could
are.
really be a paradox here. And in the third process, it's the same problem with the diameters. So in the first process, it doesn't really matter whether a chord is a diameter or not, because we're just choosing a point on the circumference of the circle and we're fixing it. So like symmetries don't really matter there. But when you start talking about the midpoints of the chord in question, if the midpoint is one that is shared by many chords, I think there should be a problem here. Like, I don't think that all three of them are equally valid answers, which is what was implied both in the class and also in like assignment 0 that we were given. Am I
Yes,
right here, or am I like there's something
yes,
off?
yes, yes, you are right, absolutely right. Like we have different answers and we have different processes as well. We can have multiple processes for that also. So that is what we are trying to say, that we are assigning probabilities in different ways. like it's just a intuition, like that is what they are trying to say, that there is no mistake in it, but each is assigning probabilities in different ways. There may be many like ways, so that because of this infinite sample space here, so we can have multiple ways of this as well. That is what is your question, if I'm not if I'm correct.
Yeah, so I'm asking if the second and third processes are equally valid. Like, I don't think they're as correct as the first one is, because they're counting many different samples as the same sample. You know, if we were to uh, if we were to draw all the lines that we could on the circle, I think that the second and third process would oversample some of those lines,
Yes.
unlike the first one. So again, I was just asking how it is that we're saying that the second and third answers are also correct.
This is just like I'm not getting exactly your question, like how second and third are correct, because it's just the intuition we are trying to make, that where we'll keep that chord, and how can we say that this is the probability that that chord will be greater than that triangle side, basically. That is just the intuition. We are just saying, inferring. This is not any specific that this is correct or that is correct. It's just the possible ways I am saying that we can put that chord there, or we can put the chord like in the third process somewhere randomly. We are putting the distance and then putting there. As you are saying that yes, they can overlap. Yes, that is true. Just we are trying, that whole example is trying to say that there might be many ways. This is just the inference. That is why we are trying to solve this example, not that we have a particular solution for that. Am I justifiable? Like correct?
I think
Anyone
so.
want to add it?
Thank you.
What's the other view? What are the other people views about this? Why we are solving and how? Yes, come on. Yes. Class is whole silent. Okay, so if it's where were we? I think it's equally valid. Yes. So we said that if it falls in that inscribed circle, and then what is the circle's, I can say the radius of that circle if it falls in that 1/2, and the above one, as we discussed, that is 1, so it comes to be 1/4. Similarly, the third process is also followed by taking the chord from the center, randomly picking, like I'll draw here only the distance OF. Basically here the F is, okay, wait a second. Now I want someone to explain the whole process so that we can get more insights. Yes, someone. Please, someone can mute your mic and explain. What are we doing here? And how we can say that probability of DE. This is just, we're trying to say that we can have multiple solutions. It's just the intuition of that only. There are many ways to like define the subset E, basically. I leave up to you. Please, someone can explain. Write in the chat only. Come on. Yes, come on. What is the probability of DE greater than AB in this case? Can I say if it's an inscribed radius, then only, and that point is basically 1 by 2. Yes, how 1 by 2? Can you explain in the, we know that only the midpoints lying within the interior circle with radius 1 by 2 are greater. Absolutely correct. So they are 1 by 2 and the circumscribed radius is 1 here. So that is why we came up with 1 by 2 by 1, that is 1 by 2. Any doubts till now? Let us have interaction rather than only me speaking and try to learn it together. Okay. Okay, there was discussed in the class about true positive, and first of all, let us try to understand what is true positive, what is false positive, what is true negative, and what is false negative. So in respect of COVID-19 only, let us first try to understand. Can someone tell me, unmute your mic and tell me what are all of these? Then we'll discuss about that. Yes, come on.
Ma'am, true positives are those which are really true COVID-19 positive and are tested positive also.
Okay.
Whereas false positive are those which are not really COVID-19 positive but are tested positive. And whereas true negative are those which are COVID-19 positive but are tested negative. And false is when they are not COVID-19 positive and neither tested positive.
Are you sure about false negative? What you told? They're tested negative
and aren't really COVID-19 positive.
Here you have done something. Is he correct? Someone can tell me.
I think false negatives are things that are actually positive and are accidentally tested negative. So they have COVID-19, but the test was negative.
So yes, you are absolutely correct. So what we are saying is try to go from right to left. They are tested positive and it is true that they are having COVID-19. They are tested positive. Wait a second. Yes, they're tested positive and actually it's false that they are actually not having COVID-19. They're tested negative and it is true. They are actually having COVID-19. They are tested negative and it is false. Actually, they are tested negative. Actually, they are having COVID-19. You got it? How to relate? Like tested negative and it is false. Actually, they are having COVID-19. True negative means tested negative and they are actually not having. That is true. True negative. Go from right to left. Is it the correct way? You got it? Someone answered, I think. Preshit, you got it? Okay, let's proceed. Okay, ma'am. Okay. So there was a question there, like I'll just go through this. Like 80% of our probability, 80% of test is accurate. So they were saying we can't say that I have COVID-19 is 80% only, because many external factors are also dependent. We can't say about that. We have to require the knowledge, like how many are actually having COVID-19 or how many tests are positive in general. So they have done an approximation. Let us go through it. True positive plus false negative. Second is true positive plus false positive. So which means that the first approximation means that they are positive and actually tested positive. And false negative means that they are tested negative, but actually they are having the COVID-19. And suppose they have said that 1 is less than 2. And I'll also tell that they have inferred that false positive is less than false negative. Now someone can explain me what does it mean, like through COVID thing, and this is okay. This proper maths is there, equate and cut off, and then if 1 is less than 2, then we can say false positive is less than false, greater than false negative. But what does it mean? What does it mean? Like earlier she told about like what is, and I also told that what is. Now you can answer that. Come on. In context of COVID-19, what does it mean? The test is less accurate, that I got it. But what does it mean for false positive is greater than false negative? As you told that, and as we discussed that, suppose a person is tested positive and actually is not positive, is greater than the test when it is negative, the test is negative, and actually he's having COVID-19 basically. So here was the case that 80% of time he's having 80%, like suppose he tested positive also, then also there is an probability that he'll not be having COVID-19, which is greater than false negative. So that is why it makes the testing survey complicated and misinterpretation is there. So this was the intuition, and I think this similar question was also asked in assignment, if I'm not wrong. Then the test is less accurate. Okay, this is the same comment. Let's go through some more problems now. And one more thing. Okay. Something which is left I want to see. I'm also thinking that we'll make a group in Slack where I'll give you the link of that Slack next time. And whosoever is having any doubt, we can share in we can discuss in that Slack group only. So thinking. We have discussed about this union and all of them. Let's leave it because this is the easy one only. I think you can do it. Okay, you understood this lemma. Can I map to probability if I'm taking A, B, C or something? Can I map to that? Yes, come on. Someone can explain me. Yes, yes. Come on. Am I audible? First place. Okay, now can someone answer? Is it same as? If yes, how? Is it the generalized formula? If I take this 3, then can I, will it, I'll get that only? If yes, then how? Can I say that if my set is, suppose, let us take my set cardinality is 1. This cardinality number of elements. So if I put here s minus 1, that is 1 minus 1, that is basically 0. So which means I'll add the individual element here. I'm taking 1 here, so I'll add here I'll only add the individual element, which means probability of A plus probability of B plus probability of C. Now I'll take s is equal to 2. When I'll put here minus 1, 2 minus 1, that is 1. So I'll get this as minus 1 here, minus 1 raised to power 1. Can be, yes, yes, it can be proved by mathematical induction. I'm just giving the intuition. Like, can we map this to the same? Because when we see this formula, we don't get the intuition like how these are equal. That is what I'm trying to give. So if I have s is equal to 2 cardinality, which means 2 I'm taking together. So which means that here it is minus 2 minus 1, that is 1, minus 1 raised to power 1, this is minus 1 only. And now I'm taking 2 cardinality, so which means minus A intersection B minus A intersection, sorry, minus taking 2 pairs of them. Now, if I say that it is basically 3, then also again it is positive, and I'm taking 3 together. Am I getting the same basically? Any doubts? Can someone give me the overview again, what I have said? Yes, come on. One more thing, assignment 0 is submitted. And what about assignment 1? Is it also submitted? So that we can solve that also. Like the deadline is gone? Or is it still there? Okay, no doubt. So you all got the intuition, like how this is equal to this, basically, when we are taking 1, when we are taking 2 is cardinality, and when we are taking 3, how we came to this, basically.
Excuse me, ma'am.
Yes.
Excuse me.
Can you please
Yes,
help me
yes.
how to read the generalized form? Can you please read it? I don't know how we should read it.
Okay, this term basically,
Yes,
which
the
one?
first one, yes. That is written in the first line.
This
yes.
one. Huh?
Mm.
Can you try to read it? I'll correct you. It's fine. Yes.
I don't have any idea.
What is this? Union?
Union.
This is intersection, you know?
That I'm clear. I don't know how to frame it as a sentence. It's a probability of AI where union ranges from I ranges from 1 to n.
Yes, correct.
Is equal to
Summation.
is that summation. S is less than or equal to.
Actually, it's a subset of n. It's
Okay,
just
S
because
is a subset of n.
And it is not equal to 5 basically.
It's not equal to pi null set, right?
Yes.
And minus 1 raised to the power s minus 1.
And then we are doing the intersection of everything.
Can you read it, ma'am? Probability of?
We are doing the intersection of everything. That is what now. Let us come to here. What is this? This is the same. We are doing the union.
I understood the next step.
Yes. This is the intersection of everything. Whatever the I belongs to X, I belongs to S, and intersection of AIs.
Okay, ma'am. Okay, thank you.
Okay, let's go to more problems. Okay, let's, as we have done De Morgan law, let us see whether it works or not. These are just basics. That is why I'm going to and fro here. From next class, we'll go through the conditional probability. We'll go in the order basically. So if I say that question is whether it's equal or not, let us take with an example. Let A be set of outcomes where roll is an even number. Let B be set of outcomes where roll is greater than 3. Now calculate and compare both of them. Left hand side and right hand side, whether they follow or not. So if I say that what is A union B whole complement for this? First of all, what is A? 6-sided dice, normal dice. Yes, come on. I should tell like 2, 4, 6. What is B? 4, 5, 6. Wait a second. What has someone has written something else? 1, 3, 5. No, it's not 1, 3, 5. We are saying that set of outcomes where roll is even, that is 2, 4, 6, and set of outcomes where roll is greater than 3, obviously that is 4, 5, 6. Now what is A? It's fine. A union B complement. Can I say 2, 4, 5, 6? That is, sorry, A union B. Now what is the complement? 1 and 3. Now what is A complement intersection B complement? What is A complement? 1, 3, 5. What is B complement? 1, 2, 3. So 1 and 3. A basic example of De Morgan's law, basically. To say that the De Morgan's law is satisfied. Yes. Now, can we say that after this we'll last half an hour we'll go through assignment 0. First of all, can someone tell me assignment 0 is submitted or not? Like whether I'm allowed to, like, is it submitted? The deadline has gone. And if the deadline has gone, then also you guys can submit. If you guys can submit, then I'm not allowed to discuss the problems here. If it's not submit, okay, no, it's not submitted. Assignment 0, I'm asking. Yeah, like deadline has gone. Come on. Was assignment 0 having deadline first thing? Okay, I was thinking to discuss with you. It's fine. Okay, A complement intersection B. 28 is the last date for submission. But is it not for assignment 1 if I'm not wrong? I don't think there was any deadline for assignment 0. Okay, then we can discuss the assignment 0 as well. And assignment 1, okay, that week 1 is assignment 1. Then assignment 1, I'll give you some insights, but obviously it's not allowed to. In the next week, we can discuss about that, but now it's not allowed. And is it like if assignment 1 deadline is gone, then also you can submit, or it's not allowed then? If you can submit after the deadline also, then we can't discuss that, or we can discuss the similar problems next week. Okay, write in the chat. I'll continue. Let us see again through the Venn diagram. If this is A, this is B. A complement intersection B. Can I say that A complement is this portion and intersection B? What is A complement intersection B? Can someone tell me? Only B. Yes. So this portion basically union A complement intersection B complement. A complement, which is this portion, intersection B complement. Can I say this is equal to A complement only? Outer region. Yes, absolutely correct. Now, second thing, if I say that A intersection B complement. A intersection B complement. Which one? This one. Union A complement intersection B complement. Can I say again this? That is a B complement. Likewise. Now what to say about this? A intersection B complement. A complement intersection B union A complement intersection B complement union A intersection B complement. Can someone tell me? I am given here A complement. We have find out that A complement is equal to A complement intersection B union A complement intersection B complement, and B complement also. We have found that A intersection B complement union A complement intersection B complement. How can we find this? Yes. How can we prove this? I mean to say. I have to prove this. These things are given to me already. Like we have proved it. How can I prove this? Think we have just used it before only. What we'll do? What should be the next step? Do the union. How I can do the union? I want to find A intersection B complement. Can you tell me about how to find A intersection B complement? How the union? Yes, you are going in right direction. Using both equivalent A complement and De Morgan's law. Yes, absolutely correct. I can say that A intersection B complement is equal to A complement union B complement by De Morgan's law, and then by doing the union as earlier also someone has told that using the union, then we can come up with this. Simple. Now, okay. Okay. Let us take that probability of okay, I'm not writing a question here, just simple. Like suppose there is a one of the student, like the students are 60% of students are genius. I can say that the probability of being genius is, sorry for the disturbance here. Probability of being a genius is 60%, and probability of suppose the students who love chocolate is 70%, and suppose that the people who lies both in genius and who loves chocolate is 40%. Let us take G, C, and this. Now, what should be the probability of G complement intersection? I'll say, sorry, I'll not write it as like this only. So, what is the probability that student is neither genius Am I audible? Yes. So I'll give you 5 minutes. What 2 minutes? Whenever someone will answer. Yes, come on. 10%. Yes, you're correct. How 10%? Let us see. So we have to find that probability of G complement at C complement, which means that he is neither genius nor chocolate lover. Yes, 10, correct. So I can say that this is genius, this is chocolate lover, or I can simply now write it as by seeing this Venn diagram only. Let us say, can I write it like this? And then opening this union G complement plus C, sorry, probability of G plus probability of C, G intersection C, and then substituting the values 0.6, 0.7 minus 0.4, which is 0.1, that is 10%. Okay, now let us go through the assignment problems. Assignment 0 problems, because assignment 1 is not yet submitted, so not allowed here. So everyone, can you open this assignment 0 on your systems so that it can be easy? I don't have to write the whole question. It's not opening for me. Some network connection here. Is it opening? Maybe some site issues or something. Is it opening assignment 0? Am I audible? First place? Yes. Some server issues, server not found. I'm getting the issue with that. Wait a second, I'm trying to open it. Have you guys tried to solve this assignment 0 as well? Yes. Okay, suppose let's start from the last. I'll not give you the K24. Suppose you roll a standard 6 die twice. What is the probability that it is a composite number in both the rolls? Yes, someone can answer. What are the composite number in one dice? Like, what are the composite number in die? First of all, how many composite number? Please explain the solution of assignment 0. Yes, I'm trying to explain that only. So let us see. Suppose you roll a. Okay, I'll write it. So question 1 says, roll a standard dice twice. Yes, come on. 4 and 6 are composite. Yes, you are correct that 4 and 6 are composite. Then what is the probability for one die rolling? That is 2 by 6. And second, as it is independent, 2 by 6. That is 1 by 9. It's not in the one. Am I doing something incorrectly, or the options are incorrect? Because I think it should be 1 by 9 only, because 4 and 6 are the composite number. And if I say that like, what is the probability of getting 4 and 6 in first die? It is 2 by 6. What is the probability of getting options are incorrect? Yes, that is what I am also assuming, that they are also 2 by 6. Okay, let us go through the second. Is it you got it? Like, what is the probability of getting a composite number? I have only two composite number in the dice, that is 4 as well as 6. So 2 out of 6, I'm having the probability of getting a composite number. Same with that, the other dice, as they are. Okay, I'll come to that independent and all in the coming lectures. So multiplied with each other and 1 by 9. Suppose you roll a die n times. Okay, now I am rolling the dice n times. What is the probability that you get a number with strictly more than 2 factors in all the rules, in all the n rules? What is the probability that you get a number with strictly more than 2 factors? Yes, someone can explain me? Come on. You're having the assignments. Second question is its generalized version. Yes, you are correct only. It's its generalized version only. So I can say that that is also 1 by 3 power n. It's that only. Suppose I'm rolling it twice, so I'm getting, okay, I'm getting 1 by 3 if I roll it one time, 1 by 3 if I roll it twice. So I can say 1 by 3 power n times if I'm rolling n times. Now the third question, it is interesting. Let's see. In the course you will study, should I write the question, or are you, I think it's asking for sum to be composite. Okay, sum to be composite. So suppose you roll a standard 6-sided dice, what is the probability that you get a composite number in both the rolls? Okay. If we see the sum to be composite, then okay, let us take with your version that, okay, maybe the question is not correct. The question is correct, and we are thinking like but they have written you'll get the composite number in both the roles. They're not writing sum. Okay, let us take the sum also. So can someone tell me the sum? What is the answer of sum is composite? Can you tell me sum to be composite? Is it one of them? Like, okay, we'll come at, is it one of them, sum to be composite? Because we were assuming that both the dice are having the composite numbers, because their interpretation is like, what I am interpreting is that you get the composite number in both the roles. It's not like that both the roles sum should be composite, but still, what should be the answer if the sum, we are taking the question as sum to be composite? Okay, let us see. So 1 1, that is not 1 2 billion thi do. So what are the 2 and 4 and 6 as we have done? So what can be the possible sums here? Okay, it's 1/4. Okay, then 1/4. Okay, then they're talking about sum only, but the question here, what is the probability that you got? Okay, my wrong. So they are talking about like the sum here, but the way they have written that you get a composite number in both the roles. If you are doing it, you're getting 1/4 only. So that's correct. Let us go to the third question. Then the question is correct. We were misinterpreting it. In the course, you will study the following case study. In 1960, there was a famous TV show called Let's Make a Deal, whose host was Monty Hall. Okay. In the show, there are 3 closed doors, one of which hides the car and other 2 hides the goat. Suppose the contestant name is Bob. Bob can only choose only one door among the 3 without opening. He will win the car. Okay. Okay, this is the host here. And suppose the person who is playing is Bob, and he can win the car if he chooses the correct door, and which hides the car and gets the goat otherwise. So whenever he can win the car if he'll open the door which is having the car and he don't know which is inside the door. Suppose Bob chooses door 1. The host, okay, now Bob, okay, thought, okay, let us go with the door 1. It can be goat or, okay, any, okay, 2 doors, I'll not write here. 2 doors are having the goats and 1 is having the car. So now Bob chooses door 1 here. The host Monty that proceeds to open door 2. Okay, now Monty said, okay, let's make it more simpler. He opens the door 2 and door 2 was goat basically. Now Monty has an option. Monty was thinking to choose door 1. Like now Monty should stick to door 1 or should switch to door 3. What do you think? Yes. Yes, guys, what do you think? Yes. Bob should change. Why? Can you unmute? Okay, it's 8/36. Okay, I'll try. I'll see you with that. Can you tell me like why Bob should switch, change? It's intuition based again. 2 doors are having goat. 1 is having gate. Your answer is correct. And your 1 is having car and 2 are having goat. Now one of them is revealed that it is having goat only. Second door. Now he's having 2 options, 1 or 3. Earlier he has chosen door 1. Now he should switch to door 3 or he should remain the same only. Someone can unmute and try at least give a wild guess. Try. I'm not saying it should be correct only. Can I say that first earlier he was not aware that second door is gate? I can say that probability of choosing the door 1 is 1 by like having door 1 having the car is 1/3 and probability of both the doors having the car because earlier 1/3. Yes, correct. So because earlier the probability was 1/3, but after it's 1/2, he changed the choice. Okay, now, okay, yes, we can think about like this also. What I am interpreting is, suppose the Bob choosing the door 1 was 1/3 as you told. Now Bob and the other 2 doors are having the car is 2/3. Now this goat, it is revealed that 2 is not having the car. Now only choosing door is, I can say 2/3 now because this together was 2/3 and it is revealed And yes, I can say that now only choosing this is 2 by 3 and this is 1 by 3. So that is why we switched to the door 3. You got the intuition? Earlier? Yes. Anyone having doubts? Okay, let's move to the next question now. Merlin selects 2 real numbers and put them into envelopes. Using a fair coin, he selects, okay. Merlin selects 2 real numbers and put them into envelopes, okay. Using a fair coin toss, he selects one of the envelopes. 2 real numbers, 1 real number here, and 1 real number here. Using a fair coin toss, he selects one of the envelope and reveal the number. Okay, he told, okay, this real number is this. He asked whether the number in the envelope is bigger than 1 revealed. Can you say? Can you guess correctly with the probability greater than 1 by 2? What do you guys think? You are reading the assignment side by side, na? Because I'm not writing it. Two real numbers are there. Merlin puts into the envelopes. And okay, randomly selects one of the envelope and reveal that number. Now, what is the chance that that number is bigger than the other envelope having the number is bigger than 1 by 2? Can we guess it correctly? I'll leave it up to you. No. Yes, we can't say because it should be, there is no idea that the other numbers, because we are not having any distribution to say like either, no idea, yes. We're not having the much information to say there. Okay, what is the least number of people you need in the room so that the probability of at least 2 of them sharing the same birthday is greater than 1 by 2? Okay, if I say that first person, okay, so I'll come to the second person. First person has selected, is having the birthdays in some way, and second person having the same birthday as first, as there was no one before him, so he uniquely selected. And the second person having the different birthday, I need to say different birthday from the first one. What is the question? At least 2. Okay, different. Let us take about different birthdays. Can I say 364 by 365? Is it correct to say having different birthdays? Second person is having different birthday from the first one is 364 by 365. Now I'm talking about different birthdays. No one is having the same birthday. Because there is only one day in which both can share the birthdays. First and second can share the birthdays. So I excluded the day and said that now 364 out of 365 times he can have the different birthday from the first one. Similarly, I can write it like the third one. I'll say that he shouldn't have the same birthdays as both of them. Similarly, nth one. Now what I want that the probabilities having the same birthdays. Actually, it's more of, I can say, if we'll do this, though we can't, that is what I was thinking. Can someone tell me how this, what is the answer and how it came? Yes, someone can tell me now. Come on, let's try. Yes, come on. Yes. Am I audible? Is my voice clear? Okay. Now can you tell me, like, give a wild guess what I'm trying to do is. Try at least. What I meant by this. Come on. Okay, I'll ask you in the next class. I've just solved it also. Just I'll ask you, take the screenshot or photo, whatever. I'll ask you the question in the next class. Try to brainstorm and think about it. By hand, I think it's difficult, but I'm just giving the intuition, like what is not having the same birthdays, then when we'll come to, okay, I'll ask you in the next class. How do you know we need to take first 22 terms only? That is what it is actually tough to know, that by putting the options also it is tough because the options are so large. It can be, what I am thinking is it can be done through the programming only. That is how I have tried to solve it, by coding only. But I don't think so these type of questions will be asked, because by doing it by hand it's tough. And it's, I think, the standard problem. That's why they have taken, otherwise they'll not take, because you can't solve by hand by taking each and other option and then by computing. It's very exhaustive. Is it clear? Okay, should I come to the next question? Yes. On a given day, it either rain or it doesn't. Thus the probability of rain is 50%. The statement is true, false, looking weird, sound about right. What is the answer? Formula, okay. There's no direct formula, I think so, or I'll explore. It was just, okay. I am giving you just the homework problem right now. Try to explore about this more. What I have done, nothing I have done, just I have added up a standard formula for this. I can't say anything. I've just used in the, okay, I'll show you the next time the programming of this only. Or I want you to program this simple and then you can show me how 23 came. Is it correct? Like, is it fine? So on a given day, it rains or not. The probability of rain is 50%. Is it true, false, or looks weird, or what? Sounds about right. What about others? What about others? What do they think? Is it sounding right? I will not tell. I want to ask from you guys only. Yes, come on. Okay, you remember about that COVID-19 problem that we did, that 80% accuracy? So we can say that in that we said that, okay, the probability that I am having the COVID is not 80%. Similarly, now can you give me the answer for this? Looks weird. If it's summer, can't tell. Actually we can't tell because uh, actually it's false only, I think so, because on a given day we can't say that it is 50%. Like the similar problem we have done now only, that if the detection is detect that COVID-19 RT-PCR test is 80% accurate, we can't say that the probability that I have COVID if I have tested positive is 80%, because it depends on various other factors as well. So it is false. The next question is again related to the like that proof only, like we can get the multiple answers, like we have solved here 1 by 2, 1 by 3, 1 by 4, like putting there, taking the chords. If you want, then I can solve in the next class. Any doubts up till now? Any feedback which you want that I should incorporate the next time in the class, like more questions or something, or more intuition based proofs? It will be helpful for me also and you also. Yes, come on. I don't want one-way class. So yes. How was the class today? It was very fun. Okay, thank you so much. So any feedback which you want me, like so that I should incorporate the next time? Next time it will be, we'll level up by moving to more. And okay, if I talk about the assignment 1, I shouldn't talk about, actually, you have to do that. But how is the assignment 1? You are getting it, or yes? Can someone unmute and tell me the feedback about the class? What something you want the class for good, not solved yet? Okay, okay, okay. Thank you so much. So we'll meet next Saturday. Thank you, class. Discussing about the basics were really helpful. Thank you so much. Okay, let's meet the next class. We'll try to solve like this week 2, that is more about the conditional probability. That will be like we'll go a level up, like Bayes theorem and all. Okay, thank you so much, class. Any doubts? Thank you.